So I'd like to take a few moments and highlight the key steps to this lab. I'm going to show you more specifically some of the detailed steps you have to follow with your calculator. So remember, the purpose of this lab is to ultimately find the area under your velocity graph, or you might say the area of your velocity data. Of course, that area should be your distance traveled. I think you're going to find out that it will be. In fact, it comes out really close to the actual distance. So I assume that you gathered 10 minutes of data. Hopefully you have that also graphed. Now, once you get that data and you graph it, you get ready to find your area. The first way, use the trapezoid rule. Most students realize that the main question I have about the trapezoid rule is H. What is H? Now, if you look, I've given you a nice hint about it, and some of you from the quiz that you just took, maybe you have a better idea what H would be, but simply, it's the length of the interval. So for this problem, it's the time interval that is every half minute. But you see, you're going to learn that for this entire lab, you have to convert everything into hours. So is your interval, is your H a half a minute? Kind of, but we need to convert that into hours. And so H comes out to be 0.5 over 60. Okay, now you're still going to divide that by 2 because that's what the formula says, but H straight up is this value. So I'm giving it to you. Make sure that next time you see that, again, on a graded activity, that you get that right for the trapezoid rule. I'm going to let you finish the trapezoid rule. You're pretty much going to just use your Y values carefully, add them, and so forth. That area that you get should come out really close to your distance traveled. Now, it's usually step 3, letter B, that gives kids the most question. What are we doing now? We're actually going to use exact integrals. Now, what that means is that we're going to have to do an antiderivative, but if I'm going to do an antiderivative, I'm going to need an actual function. I'm going to need an actual equation, specifically a piecewise function, or a couple different equations that will make up that piecewise function. Now, this turns into a calculator activity. What I'm going to do is encourage you to just kind of listen. I would not start doing this with your data yet. We're going to do it with Mr. Naylor's pretend data. So can you take this, basically this graph, and can you start to turn it into some piecewise functions? Well, the 3 type that we're going to recommend is that you see if there's any linear spaces, or see if there's any quadratic spaces, and if maybe there could even be a cubic space. The one thing about a cubic, you got to be careful, is that there has to be like a max-min behavior. In other words, the points have to be lending themselves to the graph going up for at least a maximum and at least a minimum. I'll show you a little bit more about that when we get to actually my data. Now, for my first minute and a half, I'm going to kind of suggest that we could potentially say that that's going to be a quadratic. Now, ultimately, what you're going to do is you're going to get the equation of that quadratic, but I'm going to, for the sake of this little video, just say that we're going to come up with that equation. It's going to be a quadratic equation, because what I really want to show you is that you're going to do that as x is between 0 and 1.5 over 60. Again, you always have to make sure your times are in hours. So my first piece of my piecewise function is, of course, again, only for the first minute and a half. Now, as I go back up to this data, I see that I might be able to have another quadratic, basically from 1.5 to 3.5 minutes. Now, again, ultimately, you're going to come up with that equation, and I'm going to show you how to do that in a second. But let's just write that it's going to be quadratic, because what I really want to show you is that I'm picking up where I left off. That is, I'm picking up at 1.5 minutes, of course, out of 60, and I'm going to travel the whole way to 3.5. So notice that my interval starts where the other one left off. Now, I think I could make a little argument here that these next several data points could be linear. What I'm trying to suggest here is really just from 3.5 to 4.5, although that's not a lot of time. I want you to see that it doesn't have to be perfect, but if I come up with that equation, it would be some kind of linear equation. Notice one more time that I'm picking up where the other one left off. That is, I'm starting at 3.5, and looks like I'm going to get to 4.5. Of course, out of 60, because all the times have to be converted into hours. Now, I want to show you that the idea of a cubic, I want you to see here that we can kind of notice that the data seems to have this minimum maximum look to it. Notice that I went from 4.5 all the way over here to 7.5. Now, what we're going to actually do is come up with that cubic. I'm still going to sort of fill in the word cubic here, but we're going to show you just in a moment how to come up with that cubic on the calculator. And of course, it'll be from 4.5 to 7.5. Now, in order to actually get the equation for each of these pieces, particularly the one that I'm doing is the cubic, we're going to have to use the statistical feature on the calculator. Now, that's the stat menu. It's a place that we actually have been this year, not for a while though, but some of you may recall you go to stat edit, basically to get to the L1, L2 columns. Now, there might be some data in there from who knows when. You do need to get rid of it. Hit the clear button. Make sure you hit the clear button and enter, and all the data will disappear unless you want to put the cursor inside the sort of inside there and hit the delete button. Just make sure you do not delete the actual L2. Don't go up there and actually delete that. Now remember, I'm doing 4.5 to 7.5, but I know I keep saying this, but it's something you got to keep in mind. Every time gets converted into hours. So I'm going 4.5 to 7.5, but it's actually 4.5 over 60. 5 over 60, 5.5 over 60, 6 over 60, 6.5 over 60, and I hope I'm not missing any here, 7 and 7.5 over 60. So I'm also going to type in my speeds. Again, I'm just getting my data off of the sort of my graph. Hopefully you're getting your data off of your chart. And I have my velocities. Now, as just kind of a small sort of little extra, something that's nice to do, but it's not required. You could graph this data. If you're going to graph the data, you're going to need to change your window. I do suggest that you think about doing this. It's a way to kind of check your work. It's also just kind of neat to see the graph. Notice I'm changing the window to match exactly the X and Y axis from your actual car lap. We'll go up to 70 miles an hour. Now, I do have to turn on the scatter plot. That's second Y equals. And when I turn that on, so if I hit the graph button, I should see that basically that data from 4.5 to 7.5. Now, remember, the real reason we're doing this is to come up with the cubic equation. So you ready for like the main thing? We're going to go back to the stat menu. Of course, we already typed in our data, but now I'm going to go over to stat calc, and hopefully you can see the three options that we could use: a linear, a quadratic, or a cubic. Now I'm choosing a cubic because I want you guys to see how that would work. Hit enter, and I get my magic numbers. Now, if you have a slightly different make or model of calculator, you may have had to go through another sort of calculate screen, but just get to the bottom and hit calculate, and out pops these values. Now, sometimes students say, well, what should I do with these numbers? Well, you could write them down on your paper. Now, back here in space B, I gave you a bunch of space that you can kind of organize this how you want. And this is where sometimes students will actually record the actual equation that they got. Now, that equation, although it's kind of big and long, if I choose to, I can record these numbers. This is not a terrible idea. Basically, this way you won't lose track of the numbers that you got, that the calculator gave you when you did the regression. I want you to see that it's actually coming out to be an equation. It's got x cubes and x squareds. Of course, it's got these really special values. You might call them the coefficients that are creating this equation. But nonetheless, one thing you could do is you could write these down. Now, a lot of times students that write down the equation are the students that will continue to solve this problem sort of by hand. What do I mean by solving it by hand? Well, you do realize that you have to integrate. You have to integrate this equation. And remember, we're integrating from 4.5 out of 60, of course, to 7.5 out of 60, of course, just for this particular piece. Now, again, you can do this. You can show this by hand. You could certainly add 1 to that exponent and divide by 4 and, add 1 and divide by 3. And so you could get the antiderivative. You could get this by hand, and you could actually plug in your two values, your f of b and your f of a, and subtract them. And basically, once you do that, you should have the area that goes with that one piece. You could also do this by using your calculator a little bit more entirely. So the calculator using the FNINT command actually can also calculate this area from 4.5 to 7.5. But we have to kind of remember how to use that FNINT command. Now, the one thing about the FNINT command is that it requires you to type in the equation. And I know it was kind of a pain to copy that equation onto your paper. Can you imagine typing in this equation, onto the calculator screen? Not a lot of fun. So what we're going to do is we're going to actually save this equation into the calculator so that we do not need to type it when we do the FNINT command in a moment. How do I save this equation into the calculator? Well, I actually need to go back and essentially do the regression command again. Now, obviously, if I hit enter, I'm just going to get the same numbers. So before you hit enter, we're going to add one more command, or sort of one more syntax to the end of this command using the vars menu. Now, in the vars yvars function menu, did you catch that? It's vars yvars function. We can get the y1 symbol. Now, the y1 symbol, when it's placed beside the regression command, will actually take those numbers and it will paste them into the y equals screen. Isn't that nice? I'm not going to have to type all of those numbers. Okay, it's actually pasted into the y equals screen. By the way, since I already made a little scatter plot, I can sort of check and see how my graph fits the data. Not bad, but as you can see, it's not a perfect fit. Nobody said it was going to be perfect, but again, it's not a bad fit. So let's do FNINT. That's really why we came here. And FNINT is at the bottom of the math menu. I believe it's number 9. When you do an FNINT, as it says on your lab, you have to always type in 4 things. You have to type in the equation. So remember, my equation is stored in the y1 screen. So I don't need to actually type the equation, but I do need to put the y1 symbol in place. So we always type the equation, comma x, comma a to b. Now, a to b, as I've said many times, is 4.5 over 60 to 7.5 over 60. Remember what's going to happen here. It's going to actually do the antiderivative, and it's going to do the calculation for the area. None of it do I have to actually do by hand. As you can see here, we end up with 1.83. So either way, if we use the calculator, the FNINT, or if we do it by hand, we're going to end up with 1.83 miles. And I always like to tell students that that number should make sense. In fact, the distance that you travel for each one of these pieces should make sense, so that when, of course, you add them all together, you end up with your total distance traveled. So what you want to do is you want to go back to your data, your graph, and you want to start to think what types of piecewise functions are going to model that data. Of course, find an equation for each one of them. And once you find the equation, you decide if you want to do it by hand, or if you want to use F and I and T, or if you want to do a little bit of both. But ultimately, you want to find each area, add them together to get your total distance traveled. And oh, by the way, I wouldn't make any more than 5 pieces. The lab just gets too complicated. You can see here that I got 4 pieces, and I still have something I need to do out here. So I'm a little bit on the high end, but try not to do any more than 5, and you need to at least do 3 according to the directions. Now, don't forget, once you finish finding that total area, there is kind of one more last step to the lab. You're going to do a little bit of conclusions, just a real simple, make some observations and conclusions, and we'll wrap that up and call that the car lab.